Up to this point with arithmetic sequences, we've been using rules to help us generate the sequence. Now we're going to be using recurrence relations, and this is simply a way of expressing a rule in a precise mathematical language. Now there are two parts to a recurrence relation. The first part gives us the first term. The second part gives us the next term, so it depends on us having the information from the previous term. And we already know to find the nth term that it's a plus n minus 1 times d. Let's have a look at this in action and it might become a little bit clearer. So let's take this recurrence relation 10, 15, 20. So for this one we can see that our first term is 10. We can see that it is an arithmetic sequence and each time we are adding on 5. So it has a common difference of 5. So A is 10, D is equal to 5. So now with our recurrence relation, remember there are two parts. We always write the first term, so T1 is equal to 10. And the next term is equal to the previous term plus 5. So Tn plus 1 is equal to Tn plus 5. So we keep adding 5 onto the previous term to get the next term. So that's our recurrence relation. What we want to see now is how it helps us to generate that recurrence relation, term by term. So what we know first of all is that the first term, T1, is equal to 10. Now it's really important that when we're using our recurrence relation that we show all of this. We don't just write down what each of the terms equals. So T1 is equal to 10. T2 is equal to T1 plus 5. So we know that T1 is 10, so 10 plus 5 must be 15. The next term, term 3, how do we get that? We use T2 plus 5. And because we know what T2 is now, it's 15 plus 5, which is 20. So hopefully what you can see is that what we are doing is using the previous value that we've calculated, the previous term, to generate the next term. So now if we're looking for T4, we know that that's equal to T3 plus 5. And we've just calculated T3, it is 20. So it's 20 plus 5, which is 25. And of course, this is going to go on and on. Now, you might be thinking, well, I can do that really easily on the calculator and generate that sequence. But if the question asks you to use a recurrence relation, then you must show that working out. So in this example, we're asked to generate. So generate always means show all of that development of the sequence and graph the first 5 terms of the sequence defined by the recurrence relationship. So that word generate is extremely important here. So our recurrence relationship tells us quite a few things. First of all, T1 is equal to 24. So it tells me that my first term is 24. And then the second part of my recurrence relationship tells me that I am going down in 2's. Tn plus 1 is equal to Tn take away 2. So my common difference is minus 2. So let's use that information now to generate the sequence. We know that T1 is equal to 24. Okay, the next bit, T2 is equal to T1 minus 2. So if T1 is 24, 24 take away 2 is 22. To find the third term, because remember we have to find the first 5 terms, T3 is equal to T2 take away 2. And because we've now got T2, it's 22 take away 2, which is 20. T4 is equal to T3 take away 2. And again, we know T3, so it's 18. And T5 is equal to T4 minus 2, which is 16. The graph of the first 5 terms of that sequence is something that we've done before, where we have the term on the bottom and the value on the vertical axis. Always make sure that you've got a good scale happening there, and we know that it's an arithmetic sequence. We know that we should have a linear graph and it should be decreasing, which it is. So in part 2, we're asked to use a rule to calculate the value of the 33rd term. Now we know the rule, Tn equals a plus n minus 1 d, and we know a and we know d, and because we want the 33rd term, so we've got, let's just write what we've got. A is 24, d is minus 2, and n is 33, because we want T33. So when we substitute that in, just be really careful with our signs. We know that we're multiplying by d, which is negative 2. And so once we work that all out, we get negative 40. And if you think about it, that's a feasible answer because we are going down. It would have to be something in the negatives. So it does make a lot of sense.